This is question 5 from last year's exam. It was a full hypothesis test, a matched pairs t-test. I think the question doesn't just say like what evidence or something like that. Does the data provide? By the way, do the data provide? That bothered me. Shouldn't it be does the data provide?
Data is plural.
So do the data makes sense? Okay.
I thought data is like collected for a singular. As in like.
That's what I don't know. It bothered me. The wording of the question bothered me last year. I remember that specifically. But anyway, do the data provide convincing evidence that on average women pay more than men in the country for the same car model? Okay? So you're given a lot of information. And this question literally takes up an entire page, just the question. Okay? But really you don't need half of the stuff that's on the page. Did you figure that part out? Like you can really just kind of sort and pick through what information you needed. And the only thing, well, not the only thing, but one of the things you needed was that difference. They already did the subtracting for you. So you see that there. What told us that this was a full hypothesis test question? Provide convincing evidence is a red flag clue that we should be performing a hypothesis test, okay? Interestingly enough, if I remember correctly, because it has been a full year since I've looked at this question, but if I remember, even if you didn't do the correct test, you could still get partial credit on this question, okay? So it depends on how the grading rubric was broken down. But the primary goal was to basically set up and perform the correct test, which was a matched pairs t-test. They're looking for you to state the appropriate hypotheses, the test procedure. Did you name your test? Did you say matched pairs t-test on your answer? Because identifying the test, if you remember, is usually part of the grading rubric. And you can read the rest of that. Calculate the test statistic and p-value. Yes? As a grader?
Yeah.
Yes. I actually had someone write me a love letter last year. To me, dear AP grader. And they just wrote this whole letter. It's one of the, not me, but not in my table, but I probably shouldn't say this. But let me pause the recording. Hang on. But yes, we have to read everything. Question. So if you name this as a matched pairs t-test, then you have to treat the hypothesis as so. So the only way that you could write the hypotheses is the way that they're written here. If you wrote that the mean of the males is equal to the mean of the females, what is that? That's a 2 sample, right? So that's different. So you would get docked points for that. Okay, you would not be an E, you'd be down to an I or whatever the grading rubric would say. So this is the only way that you could write. Yes?
So what if you got the null? Or, yeah.
We'll look at how the grading rubric was.
Okay.
You did a 2-tailed? I think that's, I don't know, but we'll look at that, okay? All right, so here we are. So it says that you identify the correct test by name or formula. I don't know what they mean by formula, quite frankly. I understand what it means for formula when you talk about a confidence interval, because there is a different formula for every confidence interval. But for a hypothesis test, the test statistic alone I don't think is enough. So I think you really have to name it. Okay, so you just have to write the words to matched pairs t-test on your paper. Let's keep going. You had to check your conditions. Okay, and the conditions were randomly selected. It was 1 sample, right? Randomly selected. The population of price differences is normally distributed, or the sample size is large. What was the sample size, by the way? 8. So what did you have to do? Were you told it was normal? Uh-oh. So the dot plot was introduced to show shape, right?
Yeah.
Okay. And you could have that should have. Oh, that wasn't a dot plot. What was that?
What was the dot plot?
Hang on, can I look? Hunter, that's Hunter too.
Box plot, basically, without the box.
Yeah, it's more of a box plot, right? Without the box in there. Anyway, okay. Let's keep going. Your test statistic, did you get 3.12?
Yeah.
And your p-value with 7 degrees of freedom was very small at 0.008. Okay, so you would reject the null hypothesis because you had this. I remember this specifically last year being a problem. You have to say, when I say the word linkage, what do they mean? Link your p-value to your alpha. Either say that 0.008 is less than 0.05, or say that 0.008 is so small that we're able to reject the null. But the word, when they say linkage, and it was a big discussion last year at our grading, was being able to make sure if they didn't provide linkage, then we had to dock them. We couldn't give them full credit on that question. 0.008.
How do you find
How do you find what?
the p-value based on the distribution?
Based on the test statistic?
It's 7 degrees.
So you would have to do, well, so your p-value, so you're going to do your, whatever it is, 0, 3.12, and was it greater than, was that the, okay, so it's greater than, and then you would just, when you type it in, it would be TCDF, and you would do 3.12, E99, and then the degree of freedom was 7. And that would give you your p-value. Okay? Lower bound, upper bound, and then your degree of freedom. But you always, and when you use the t-distribution, you always use your test statistic. When we did normal, we could have not used our z-score and included our mean and standard deviation. Okay. We're specifically looking for this number and that number. That was specifically step 3, those 2 numbers. Okay? And honestly, we were allowed to give full credit if you just wrote what the numbers were. The calculator gave them to you. Done, done. I'm just saying last year, who knows? Huh? They are, and that's what's so confusing sometimes is like, how do I know how much work to show? Just do it, okay? Just to be on the safe side. You know what I mean? Like, just show the formula. It's not that hard.
So if worse comes to worse, should you try and show your work?
Yes.
If you're calculating, if you do a different answer, just put what the calculator gave you. Like if you're not exactly sure what you're doing.
Yes. I hate to say that, but
Like, do they look at the process and then
do I look at the process? Yes.
you check the math that they did?
I don't go back and check the exact math, but I would look for these numbers in that order and then that answer. Like I would look for this and that, but I'm not, if you have this off by a little bit and that off by, you know what I'm saying? Like I don't go and recalculate everything they do. But I will tell you that they provide lots and lots of work samples, and when we go through our training, like I told you, I graded this question last year, and I had to go through a whole day and a half of being trained on the what ifs. So they go through and pick student samples, and they provide them in our training when we grade this question and say, so a lot of kids are doing this. So you look out for this mistake. A lot of kids are doing this. What if this happens? How would we treat it? So that's kind of one of the scenarios that would have come up. Okay? All right, so conclusion and context. Let's see how that was scored. So each of the steps, 1, 2, 3, and 4, were EP or an I. And remember how I told you I have a little notebook where I literally write EPI throughout the whole thing. So I'll bring it next year. Well, you won't be here next year. You won't care. So step 1. So we had to it's essential if you identify the correct parameter and hypothesis. What do you think they mean by parameter? The mu. You had to use mu and not x bar, right? Okay, so that's what they're looking for. Did you use the correct parameter? And the hypothesis was the difference of the means was 0 as the null, and that the difference was greater than 0, right? Was the alternative? Okay. Partially, if you didn't use the correct partial, if it was the correct parameter or the hypothesis, but not both. Okay, step 2. So hopefully everybody got that part as an E. Woohoo. So step 2, essentially if you identify the procedure, which just means that you have to say the words matched pairs t-test, and you have to check both conditions, the randomness and the nearly normal condition. Step 1. Defining the parameter symbol in context is sufficient. Just saying mu is okay. Just using the mu and rather than the x bar. So if you look at the note, it does say the random sampling condition can be verified by referring to the random selection of car models. It says it in the problem somewhere that the samples were collected randomly, right? So that if you referred to that, then you would, don't just say conditions, 1, random, check. Don't do that, okay? I know you. I've graded your work. What? You should say in the context. So you should say something like the problem states that the car's models were selected randomly. And so refer to the context of the problem. Don't just say, see the first sentence that you wrote. You know what I mean? Like, don't be mean. Okay. All right. Step 3 is essential if you had the correct test statistic and p-value. And then the last one, step 4, was if you had linkage. I feel like it's sausage. Okay, linkage. Anyway, you want a context in conclusion. What did I just say? Conclusion in context. Okay, and then justification. Basically, your p-value 0.008 is less than 0.05. Therefore, we reject the null, and then your conclusion in context. So the difference between the car costs for men and women is greater than 0. Or you could say specifically, what was it? Women paid more? That would have been okay too. Okay? Anybody get, what's the EEE? Anybody?
I don't really know. When you said linkage, for the T.
That just means that if you wrote this,
Right,
that's linkage.
Really?
That's what they mean by linkage. If you don't have that, or if you don't say that this is small, you literally had to have one of those two things.
Right, but that's the expected value, right? Or p-value.
That's the alpha. That's the p-value, and you compare it to your alpha left.
I thought the p-value is
0.008. It's either, yeah. That's what it was. He did a two-tailed. All right. So that you thank you. P as in probability of Devin getting a 5. P. Okay. I'm sure it had to do with something with the two-tailed. That makes a lot of sense. So I don't know what you would have gotten. I'm trying to think in terms of if you chose so they're not going to provide that here, but that would have been one of the special cases if they chose the wrong test but did everything correct, or if you did a two-tailed versus a one-tailed. You're probably going to get as long as you did all the work correct for the test, the two-tailed test that you chose. I imagine that you would only get docked a little bit.
Well, if it's a two-tailed, the probability is 0.016. The probability would be
0.008, exactly.
for a 1.
Right. So what I'm saying is that you still would have gotten docked because your work was correct for your hypothesis, the alternative hypothesis that you chose of your not equal to, right? Or not equal to 0. So you probably would have gotten the work correct. You would have gotten docked in step 1 for the incorrect hypotheses. So you would have gotten P, E, E. E, E, E.
For what? Like because I did the, right. No. For the alternative hypothesis. Well, why was the null, or why was the alternative hypothesis?
Okay, so why was the alternate hypothesis greater than and not a two-tailed? That's a good question. So shh. So go ahead. Let's all listen to Amanda, please. Go ahead.
They're asking for evidence that women pay more than this, so they're not asking if there's different variations, but
That's asking if it's different.
Women pay more.
Specifically, no.
If you test that,
Women more than is
more than, but then if you make the test and then you conclude that men actually pay more.
you can't conclude. You cannot conclude from a two-tailed test that you cannot change your hypotheses, and you will get docked for that. Okay, so I know that for a fact. Whatever hypotheses you choose, that's the evidence you have to support. You can't say, okay, well, I did a two-tailed and I got this answer, therefore I know that I could change my hypotheses. That's kind of backwards. They won't let you do that. You have to be very linear in your thought process. You can't backtrack and change your hypotheses and make a different conclusion based on the data you got here. Okay, yes?
So if I did a sample t-test but I did all the work right for a two-sample t-test?
You would have gotten some credit. I don't, it's definitely the wrong test.
Yeah.
I don't remember, I think you got 2s out of 4s, if I remember. I'm trying to remember from a year ago, but I think it was a 2, as long as everything else was okay. So it was a developing, because you chose the wrong test. It was I think it was 2. Yes?
I know this is a weird question, but if we somehow had time to do,
Yeah.
if we somehow had time to do 2 different tests, like if we weren't sure which one of them and we did 2 of them, and wrote everything and figured both of them, would we get credit if we give one of them incorrect?
No.
No?
They're not, it's not like, oh, I did, one of them's wrong, one of them's right. I would have to, I can't pick the one that's correct. You have to demonstrate that you know which one is the right answer.
Like A or B or C or D.
Right.
A or
Yeah, exactly. Did you hear what Devin said? That's exactly right. I choose A or B or B or A, whatever. A, B, C, or D. I choose all of them, therefore I must be right. You can't do that. Okay? Yes?
Is it not like I do where I do choose the first answer you get?
Mm-mm. Yeah. No. If you put more than one answer down, I have to mark it wrong, because it's obviously you're showing me that you don't know what the correct answer is. Okay? Yeah. Okay. How many? So we had a 4. That's good. Anybody get a 3? I would hope that quite a few of us got 3s. Okay. I thought this was a very fair question. It really is just kind of a regular old hypothesis test. I think what bothers me about the question is there's so much information given to you here, sorting through what matters and what doesn't matter, right? I think that takes 5 minutes in and of itself sometimes, is just reading the darn question. But that's what we had to deal with. All right, so go ahead and put this away. Keep it, though, because we're going to use the back of that next week. There's another question. I think it's question 4. You promised me you wouldn't sleep if you were comfortable, Brian. Didn't you? You promised. You pinky promised, if I remember. I think you pinkied. Pretty sure. Hurry up, Zachary, because take the pass and be careful. So in topic 1 here, this is the answer to this question was C. Okay, we'll come back if we have questions. Or I actually won't come back. Are we okay with that? We'll just go one at a time. Good? All right, the next one, topic 2, we have lots of stuff to cover. And in topic 2, we have a World Series question here. And the answer was A. Any questions about how that happened? Did I skip one? We're not there yet. All right, topic 2, the next question. I have D, E, E. Yes, Y. Okay, why is this one? All right, so why is number 2 not a Roman numeral 2 not correct? Okay. Okay. The interquartile range is half the distance between the first quartile and the third quartile. It's not half of it, it's the entire distance. So the word half is what makes that wrong. Okay? But everything else is correct for 1 and 3. Fair enough? Okay. Next question. This is the one where I think I gave you the histograms, did I not? Or no?
Yeah.
I did for this one, I believe. And I asked you to draw, I believe, a box plot that would have matched the histogram, correct? So just kind of as a backtrack here, I believe the histogram looked something like that. Would you agree? Very skewed left, if I remember correct. And that's really what I wanted you to be able to do, is draw some kind of skewed left box plot. What does a skewed left box plot look like? Okay, so that we have a left whisker, right? And then what about a box? Okay, do I have any whisk? That's not right. Do I have any whisker to the right?
If you do, it's very small.
Okay, I don't even agree with that question. I don't even agree with that. I don't think that. I mean, to me, I think did I give you the heights of the bars? Okay, so this one was up to maybe a 6, is that right? And that one was 3, 2, 1, something like that? I don't know. So where's the median lie? Doesn't it lie right here? Right? Okay. So depending, right? So in other words, the box is only like that. The median and quartile 3 is the same? Right? Yes.
What if we like misinterpreted the numbers? Like,
Well, I asked you to draw it on your own rather than match it. I think if you saw other ones, you'd be able to match it pretty well. Yeah? Okay. Yes. Sammy? You're just stretching. Getting your promposal arm ready with the bat. I'm confused. I'm scared about that. All right. Excuse me. All right, this question was E, the last one. We did this like the first week of school, if I remember correctly, long time ago. But when you actually have a mean and standard deviation, and you're increasing by a percentage, what is affected? If you're multiplying, which is what that means, what gets multiplied? Everything gets multiplied. Okay? When I add something, what changes?
Just the mean.
The mean, the standard deviation, the median would change too. The standard deviation doesn't change. Only the measure of center changes. Because if you think about it, like remember, I think we did this with little whiteboards, if I remember, at the beginning of the year. And we said, okay, we have our little whiteboards, and we said, if I multiplied by something, what happens? And then it went like this, right? And it got really large, but like the 0 person stayed at 0. Do you remember that? And we multiplied, which means the spread greatly increased. The measure of center went over there too. But if I added, didn't we all move together and we added together? Which means the spread didn't change, but the measure of middle did. Okay, does that make sense when I say it that way? Hopefully. So in this case, increasing by a percentage is multiplication, which means that we are changing everything. Okay? All right. Oh, did you have a question, Abby?
No, I was wrong.
We'll go with that. When there are multiple gaps in clusters, which of the following gives a best choice for the best overall picture of what's happening here? If we know there are multiple gaps in clusters, maybe even an outlier or two, we want a best overall picture. What's going to show that? What's going to show gaps? Only those, right? Only that will show gaps. Box plot will show shape, but it's not going to show gaps, okay? The 5-member summary won't either. The box plot would show outliers, though, wouldn't it? The outliers are shown, but the gaps was the key word there, okay? All right, what did you think about this one? If the standard deviation is 0, what can you conclude?
There's no variability.
There's no variability, which means everything is exactly the same, which means that all the observations are the same value. Okay? Good. All right. So I'd like to look at 46 because I want us to be able to answer this question. Notice how I said to myself, draw the graph. That doesn't help you if you didn't have it. So I'd like to look at it right now if we could. So let me go ahead and draw this graph for you. And then let's decide what kind of an answer we're going to have. All right, I'm just going to give you a kind of a scale here. Mm-hmm. All right, because I'm having to draw it, I'm concerned that it's not going to be perfect, and it won't be, but we're going to estimate it. At least practice how to use an ogive. How's that? Okay? It might not be one of the answers listed here, but we'll be okay. Right. How did you know it was an ogive? What brought that thought into your head, by the way? Yeah, and it's not labeled as a frequency, but it is a relative frequency over here. And why am I calling it a relative frequency as opposed to a frequency? Because it's out of 1. It's a percentage, right? It's like out of 1. So it's 0.1 to 1. And how do I know that it's really a cumulative relative frequency? Well, the shape, right? It's not really S-shaped. It kind of more is a mountain shaped, I guess. I don't know, but you hyping yourself up over there? Getting all worked up? Let's go. Let's go. Can we all go down and watch? Yay! Okay. I told you I'm delirious today. All right, IQR. How do I do it? What is it? Q1 and Q3 I need to find, which corresponds to what in terms of percentages? 25% and 75%. So, okay, so hang on. So 25% would be, and I have to, well, that's not right. We have to be perfect. So 25% really is like this, right? Now, as a reminder, you have paper that has a corner on it, right? So I would suggest you use it and line it up at where you think 25 is, hit the corner of your graph, corner of your paper on the graph itself, and draw your line straight down, okay? The graphs that are provided by AP will have some sort of grid along the back, like the background of it. It won't be drawn like this, so it'll be more exact, okay? But I think we're going to estimate that to be 250? I don't know. What do you think? We're going to, because that's what it says on my paper. Okay? I didn't draw it right. There you go. We're estimating. Obviously, you would be more exact. All right, then we have to find, so we're looking for 25% here. And then I'm going to go out to 75%. Really, I'm not going to draw it straight. So about 75%, and we're going to, let's see how it's supposed to be. Oh, I'm pretty good. And this is 1800, right? Okay. Obviously, it's not exactly. I probably would have estimated that to be about 17, but that's okay. And then you just subtract them. And when you subtract those, what do you get? Not an answer that's up there. Oh yeah, 1550, it's up there. I'm a liar. So just making sure we remember how to find medians or interquartile ranges or any of that using an ogive. And we kind of remember, right?
Do you think you're going to get asked to make an ogive?
No, I have never, like I said this last class, I think, I've never seen on an exam they ask you to create any kind of graphical display. They just want you to interpret what's given to you. All right, so the next questions, this is one where all of them you had to have dot plots and you had to have the graphs, right, to be able to answer these questions. Draw the histograms. So how about we just kind of answer a question where what would the histogram look like if both of them had the same mean? What would that have to, can you draw two, never mind, I'm just going to give you, just make it two. How about this? If I drew two box plots, or not box plots, histograms is what it's supposed to look like, right? And I did, they look like Lego pieces, but what would you say about these? Let's say the scales were the same, okay? The horizontal scales were the same. What would you say? They're both symmetric. Okay, but what about this information? With Roman numeral 1, Roman numeral 2, Roman numeral 3. Do both sets have the same mean? Yes, they do. When they're symmetric, no matter what kind of symmetry it has, the mean is in the middle, right? So yes, they both have the same mean, assuming that the scales are the same. And I told you they were. How about the range? Yes, they both have the same range as well. What about the same variance? No. So the answer is 1 and 2, which I don't have as an answer, which is great. So I guess none of the above, which is what it would be, right? Because it's none of the above in this case with this picture. But we want to know that it is 1 and 2, not this one. Which one has a larger variance? The top graph or the bottom graph? Oh, I heard both. The top one does. What does variance mean, or standard deviation? How far the data is away from the middle? Right, so the further the data is away, the higher the variance is going to be. So this one has a larger variance than the one down here, correct? Okay, that was kind of the general feel of this question. You don't understand? Do you understand why 1 and 2 are correct? Okay, so when you have a small variance, the data is more centered around the mean. And so here is our mean. It's centered around that value. So it has a very small spread, where here is the mean, and a lot of the data is on either side of it. It's not centered around that. So this has a larger variance than this one. Here's Mrs. Mackert. No, I'm just kidding. Okay. It's okay. I was on the debate team. I loved it. All right, next question. Which of the following are true statements about box plots? Let me get an idea of what they were thinking about for here. Okay, so I'm just going to draw 2 box plots. Yes, assume that the, exactly, as long as the scales are the same, no matter what I've drawn for the second graph, the ranges are the same. Would you agree? Okay. No. Nope. The way that they're drawn, there's no outliers drawn. We're just, that's it. That's the whole graph. Okay, so the ranges are exactly the same. So you were right to begin with. What do you think about that one? Are the IQRs the same? Because the boxes, right, the ends of the boxes represent the IQR, Q1, Q3. And then symmetry, the medians are the same? No, which one has a higher median? The bottom one. Good. All right. So yes, yes, no, 1 and 2. Yay. All right. Okay. Topic 4. Let's see how we did here. So I think we're back to looking at things that maybe you could have answered. On this one, I got E. This is basically interpreting the slope, isn't it? Can you, in the context of a question, interpret what the slope is? Okay? The meaning of the slope, and that's what it was here. Okay? The next question, the answer was, ooh, what do y'all think of the next one? The answer was 2. Huh. So, do you guys vaguely remember having to take the log of a variable and all that jazz from a long time ago? Where you take the log of x, the log of y, or the log of both, and what happens is either linear, it's either quadratic or exponential, logarithmic. I forget. Good question. Yes, I do. But so here is the original value, right? And it's asking with a relatively low correlation, which bothers me because that correlation should be a lot higher if you're going to straighten out the data. Shouldn't your correlation be like 9.9 or something? But anyway, we're going with it. What we need to do here is if we plug in, well, I'll come back to why that one's true in a second, okay? But why can we rule out 1 and 3, I guess is a good question. Why are we able to rule that out? So for Roman numeral 1, on average, ooh, we don't say that with regression, okay? Just ever. So, right, okay? Roman numeral 3, 53% of the variation in revenue can be explained by variation in time. So that sounds like a sentence we used to say that corresponded to what? R squared. So we got to find what R squared is. So 0.73 squared is 0.5329. So it's about 53%, but what's the problem? The variables are switched. Okay? So you have to have, it's always the variation of y that can be explained by x. So it's going to be the variation in time that can be explained by revenue. Okay? So those are backwards. So that's the issue. And then y is 2 correct. Okay, if I plug it in, what am I plugging in?
You put 5 in X.
Right, so if I plug in a 5 for x, I don't get 59 million. Tell me what I do get. Which is why on this question, I believe most people would answer E, none of the above.
Yes.
But that's not correct. What did you get here?
4.77.
As did I. Okay. The problem is that this says the log of y, or the log of x, I'm sorry, correct? So we have to think about the log of x, okay, and its relationship, and you may or may not have been taught this back in Algebra 2, and this is why this is one question, and if you don't get it, who cares? But for those of us that actually care, the log base 10 of y, the log base 10 of x is equal to y, which means that 10 to the y is equal to x. So 10 to the 4.77 is in fact $59 million. Okay. If you were never taught logs and you were never taught the relationship between logarithmic equations and exponential equations, then you probably couldn't answer that question. Don't worry about it. Okay? It's one question that probably won't happen on the exam.
Will it always be big?
It could be, no, you could have a natural log. Any base is fine, actually.
So if it's like a common log,
Any log would work.
yeah.
Doesn't matter what the base is. Okay, you ready? Can we move on? I'd like to. All right. Let's see if I have an answer. If not, we're going to, no. All right, so let's just talk about the relationship between scatter plots and residual plots, okay? Because I don't have the pictures drawn here. Oh gosh, time flies when you're having fun. It's got to go. Tanner's thinking the same thing, right? Having lots of fun? Yeah. What is a residual plot? Let's start from the basics.
Y and how far away varies from the predicted value.
That's what a residual itself is, okay? But what is a residual plot? Okay? So this is going to be your x values are going to be along this axis, and your y values are going to correspond to the actual residuals, okay? And as Charlie explained, what a residual was is it's the predicted value minus the actual observed value, or the linear distance, or the vertical distance from the actual line of best fit to the point, the observed value. Okay? Probably say it better the other way around. Observed minus predicted. We need like a movie screen. What's going on out there?
Everyone congregated or
So what are we looking for in a residual plot? No pattern at all, okay? We want randomness, okay? We don't want any kind of shape. So if there is no shape or no pattern at all to a residual plot, what can I interpret about the actual scatter plot itself or the data itself? That it's linear, okay? So we can say that, so if that is the residual plot, what would the scatter plot look like? Okay, so this would be the residual plot, and I'm going to draw 4 scatter plots, and you tell me which one it would be. A, B, C, or D? A is the only linear scatter plot, right? We have quadratic, we have logarithmic, and we have non-linear.
B would be the only one.
What did I spell?
You could argue B, because we don't have a y-axis that is inverted or whatever.
Yeah, but it has a pattern. It's logarithmic, so it definitely wouldn't have, right? Okay. Let me go ahead and just give you the rest of the answers. So here, the next one I got to be A with this one. The next one I got to be D. So all of these are correct. And the next one I got to be C. And I'd like to talk about the next one, because a lot of us left that one blank. Okay, so if I'm going to consider this set of points, I want to be able to figure out what n would be so that the correlation would be 1. What's probably the easiest way to answer this question? There's multiple ways to do it, but can anyone think of an easy, quick way? I want the correlation to be 1. Plug what into my calculator? Make a list and just plug in the answer choices and see which one works best. Anyone do that? That would, to me, make the most sense. Use your answer choices and plug them in to see which one would give you the correct, give you the best value. Okay? That's okay. But none of these work, is my point. None of them worked. Okay? Sure. You would just literally go to stat edit and clear them out and put in, so you'd be like 3, put on 3, 4, 5, and 10. Oh, hee hee, okay. That is 2.5, hee hee, okay. 2.5 is what that's supposed to say. Oh, 2 comma 5, I'm a liar. Yep, hate that when I do that. Okay, and so 5, you're right. And then 7, 9. And then I wouldn't use n, I would just use the answer choices. So I'd use 21, and then I would go ahead and I want a perfect correlation. So I'm going to calculate the linear regression, and I'm going to look for an R that's exactly 1, and it's not. Close, but it says exactly. Wah, wah, wah. Okay? Right. So you know that those 3 don't work. So why? I know that the no value will work. Anyone want to know why? Can anyone figure it out? Well, if you think about it, if you know that it's got to be linear, if I go 3, 4, 5,
But it doesn't, it's not fully arithmetic.
this value here messes it up. Okay? It doesn't make it arithmetic, linear, however you want to think about it, a sequence, you want to think about it as a graph, it doesn't matter. The first 3 terms are perfectly linear. They are an arithmetic situation. But when you jump to 10, it's not an integer value. Question.
And also with from 5 to 9, it increases it by 2 intervals. So when it goes to 9 and 12, it increases by 3, which also speeds it.
Oh, right. I'm sorry. You're right. You're right. This is not perfectly linear. I apologize. You're exactly right. 3 to 2, and then it jumps to 3. So I'm sorry. You're right. Thank you, Zachary. You're right. So it wouldn't. They're not linear at all to begin with. The first 3 aren't. So since the first 3 aren't linear, then there's nothing that would make it work. Thank you. That's exactly right. Are not linear.
It's the last 2 that
This one messes us up.
I
I don't like it because it's mad. The first 3 are perfectly linear as long as you do this, right? And so that they are, it's the 5, 12 that we don't like. Okay? All right, I wanted to at least talk about that. A lot of you left the next question because it was an FRQ blank. where you had to answer A, B, C, D, and E. So you should go back and look at that. Okay. I'm not going to assign any homework this weekend. It's prom weekend. I think you need a break. Are you going to cry? Okay. You want homework?
No, I said I want to cry.
Oh, I was like, it's okay. I'll give it to you if you want it that bad.